Water cycle on Earth. The water cycle, also known as the hydraulic cycle, describes the continuous movement of water on, above, and below the surface of the Earth. Components of the hydraulic cycle include water vapor and clouds in the atmosphere. It also includes liquid surface waters, oceans, lakes, and streams, on continents, as well as groundwater. Other important components of the hydraulic cycle include glacial ice, held on continents, and the water contained in biomass plants and animals, which are about 70% water by volume. The hydraulic cycle can be thought of as a series of reservoirs, or storage areas, and a set of physical processes of evaporation, condensation, precipitation, infiltration, runoff, and subsurface flow, all of which cause water to move between those reservoirs. And, as water moves from one reservoir to another, such as from river to ocean or from the ocean to the atmosphere, it changes state between liquid, vapor, and solid, ice. Yet, despite these continual movements within the hydrosphere, the total amount of water at any one time on Earth remains essentially constant. Most water vapor gets into the atmosphere by a process called evaporation, during which the physical state of water is changed from a liquid state to a gaseous state using energy from the sun. The rate of evaporation from soils or surface waters can be influenced by several factors, including radiation, temperature, relative humidity, and wind. Warmer air can hold more water vapor, thereby generating increased evaporation rates, and windy conditions generally accelerate evaporation. Transpiration from plants takes place via water loss from the stomates, the gas exchange organs found on the leaves of plants. Since this process is often lumped with evaporation, it is then generally called evapotranspiration. Besides, with enough energy added, water can be converted directly from a solid, ice or snow, to water vapor through a process called sublimation. The water vapor then rises in the atmosphere and cools down, forming tiny water droplets by a process called condensation. Normally, those water droplets make up clouds, yet when they combine with each other, they would grow larger and eventually become too heavy to stay in the air. Then, they would fall to the ground as rain, snow, and other types of precipitation. Most of the precipitation becomes a part of the ocean or part of rivers, lakes, and streams that eventually lead to the ocean. Some precipitation is intercepted by plant foliage and eventually evaporates back to the atmosphere rather than falling to the ground. Some of the snow and ice that falls as precipitation stays at the Earth's surface in glaciers and other types of ice. Still, other precipitation that reaches the soil surface evaporates, sublimates, runs off the ground's surface, runoff, penetrates the ground, infiltration, or percolates through soil to deeper soil layers or groundwater supplies, percolation. Whether the water runs off or infiltrates the ground surface is controlled by a number of mechanisms, including precipitation rate, soil water content, slope, and vegetation. With increased rates of precipitation, runoff rates tend to increase in extreme cases. Rapid cloudbursts of precipitation can result in flash floods and potential landslides. Prior to rainfall, the relative amount of water content in the soil can dictate the amount of water that the soil can hold before saturation. Generally, more water will infiltrate into dry soil than in wet ones, and more water will run off steeper slopes than off moderate slopes. The presence of vegetation can also counteract this process by holding more water than the hill slopes would by themselves. Often, rates of hydraulic activity are measured in terms of mean residence time, or the average amount of time that water remains in its various states or reservoirs. For example, the mean residence time of a water molecule in the atmosphere is very short, usually from days to a week or two. Water tends to move quickly through plant and animal tissue, but can be stored in cells for a much longer period of time. It can take weeks to months for water to move through surface drainage networks, depending upon the complexity of the geomorphologic network. Water may be stored for months to years in soil. Water and individual water molecules may remain in deep groundwater, glaciers, and ocean basins for decades to 10,000 years or more.